Now I want to take a look at how we write functions inside of C++. Now, functions in C++ are like functions in a lot of other languages. You're going to have a function header, which is going to define how the function looks and what variables get passed to it and things like that, in a function body. So let's look at an example of this. First, we're going to look at an example of a function that returns no value and takes no parameters. Now, the function header always starts with a return type. If we're going to return no values whatsoever, we'll specify that as void. Void meaning that it returns no data. We have our function name. A function name is any valid C++ name, which means it needs to start with a letter. It can have letters, numbers, underscores, and is going to be case sensitive. But it cannot be a keyword and other rules like that that you've seen so far in C++. The other thing we want to know is that our function name should be meaningful. So we should be able to know what this function is doing based upon looking at its name. The function name should be a direct indicator, make our code easier to read, and help us to abstract our code to save us from having a complicated piece of information and instead be able to see it in a single name. In our example, we're just going to print something out. So I'm going to have, and because we're taking no parameters, I'm going to have an open and close parenthesis. We'll now have our function body. And inside of a C++, our function body must be contained within braces, even if it's only a single line. I'm going to go ahead and write my function body. And this is a fully valid C++ function. And I'm going to now call this from my main function. We always have that main function, and that's a function that is called by the application when it runs. So we never have to make this call, but it always exists. So we've always been using a function, we just haven't really looked at it. Now we're looking at it precisely. So inside my main function, I'm going to make my function call, which is just going to be my function name, an open close parentheses, and I'll pass any arguments that I need. Now remember, an argument is a value that gets passed to the function. Parameters are received by the function. In this example, real quick, I'm going to run it, and it prints hello world to my screen, just as I expected. All right. So let's see what happens if we want to make a couple of little changes to this. So I've got here in my example, I'm not taking any parameters. My parameter list is empty. But if I want to add a parameter, I'm just going to go inside of my parentheses. I'm going to specify my parameter's data type and the parameter name, in this case, value. I'm going to update my cout to now print out the value, which is a variable I can use, and this variable is available to me anywhere inside of my function. At this point, you might notice I have a red underline saying I have an error in my print hello function call. That's because I'm not passing a value. Let me update that so it gets a value. Now I know who I'm passing it to. In this case, I'm passing a literal value. I'm going to run this. And you'll notice it prints the exact same thing. If I change my literal value, it would make a change there as well. So let's look at how we can handle multiple values real quick. To do this, I'm going to write a new function. Now in this example, we're going to create a new function, but we're going to make a couple of changes. Number one, we're going to return a value. And that's an important thing to define, is this value is that we're going to have a return type. So I'm going to start off with a return type of double, and I'm going to specify my function name. Now I'm going to specify my parameter. And my function body. We're going to first set up a constant. And then I need to return something. In my previous example, I had a return type of void. I didn't need to use a return. However, in this example, because I specify a return type, I really need to have a return. So I'm going to have my return keyword, and then I need to specify what am I going to return. Now, I can do a calculation and return a variable. I can do my calculation in my return statement if I want. And that's what I'll do just for simplicity's sake. I'm going to say pi times radius because that is my formula for finding the area of a circle. Now, inside my main function, I need to define a few things. My parameter for calculating the area of a circle is named radius, and I may have a radius variable inside of my main function, or I could have a completely different variable name. The variable names do not have to match. What has to match is the data type and the order that they're passed in. So I'm going to specify, for example, double R1, and I'm just going to go ahead and give it a value right off the bat. I'm going to define a variable called area, which I'll use later. And now I'm going to give area a value. Area is going to equal, I'm going to call my function. I'm going to pass R1 into my function. This will allow me to have different values be able to be generated by my function so I can use them as I need it. A cout function, and I can click run, and I can get an answer. I now get an answer from my function as I would have expected. If I changed my value of my R1 and run again, you'll notice now that the value of the area that it was generated changes with the change in the variable that was passed into my function. Now, there's a couple things I do want to point out about this. First off is a function can only return a single value in C++. This is actually pretty standard for a lot of programming languages. If you need to return two values, we'll have to look at some other options to allow us to do that. And we'll look at those in the near future. But for right now, we can only return a single value. The other thing I want to point out is an interesting little tidbit. And I'm going to use a floating point value. And I'm going to call this R2. I specified a value for it, declaring it. And now I'm going to create a new cout function to show you another way that you can call this function. So previously we called the function and stored the return type into a variable. That's very helpful if you want to do things over and over again. However, in this case, I'm going to specify cout, my literal string, and then I'm going to call my function. In this case, I'm going to pass in R2. When I go to run this file, you'll notice two things. Number one, the first area circle comes up. It's stored inside of a variable. Very helpful if I need to use this variable for later purposes. And the second one came up and ran as well. However, there was a big difference between these two. Inside my function, I specify a data type of double. However, R2, which I passed into my second function call, was of type float. C++ knows that a double is more complicated in a lot of ways. It takes up more memory space than a float. It was able to do conversion for me, so I didn't have to worry about that. This way I can reduce the number of functions I have to define because it can do some automatic typecasting for me. So I can move from integers to doubles, floats to doubles. However, I cannot move a complex data type to a simpler data type, for example, a double down to a float. So I can go more complicated, and this is a perfect example of it and why that happens. Now, if we want to have, for example, another function, this time we're going to specify we're going to calculate the area of a rectangle. In this case, I need more than one parameter. So what I'm going to do is I'm going to specify double length, put a comma, specify my data type again, double width. So anytime I want to add additional parameters, I'm going to use a comma to separate them out. All of my parameters, I need to define the data type and the parameter name. And I'll be able to use this parameter name inside of my function. Now, because I don't need any type of constants with this, this becomes very simple. I'm going to say return length times width. Now, all I'd have to do is I could call this information once again. In order to call this function, I do the same type of thing that I've done before. Specify I'm going to call it area of rectangle. And I'm going to pass two hard-coded values into this, 10 and 13. And it will return this value into my cout stream so I can see the results in my output. From this example, we can see the area of circles, which we had previously seen, and we can now get the area of the box based upon the values that we passed in as arguments to our function call. And that's how we define a function inside of C++ and how we call it inside of our application.